So lesson number 4 looks at conversion within the SI system. So the SI system is the metric system. We've gone through this already, so I will be going through this lesson faster because we did do this last semester. So the next 3 lessons look at conversions. Lesson 4 is within the SI system. Lesson 5 is between the SI and the imperial system. And lesson number 6 looks at conversion when we're dealing with square units and cubic units, because we have to change our conversion factors. So within the metric system, the international system of units, what we need to remember is where our starting or our base unit is in the middle. And then we have deci, centi, millimeter. This is micrometer or a microgram or a microliter. And then we have nano. The ones that you need to be able to move throughout on your own is from here to here. Okay? When it comes to the micro, the nano, the mega, and the giga, I would give you those, or I would give you a sheet that had them all listed on it. I wouldn't make you memorize them. And even within these 7, which we've been working with for several years, kilo, the base, centi, and milli are the most common. Very seldomly do we talk about decameters. We don't talk about decimeters either. We talk in terms of meters, centimeters, millimeters, kilometers. If we're talking about grams, it's kilograms, milligrams, and grams. And when we're talking about liters, most of the time it's just liters and milliliters. So I will, for the most part, except for maybe on an assignment, deal with our common units and not ask you to do conversion with units that you might not be as familiar with. When we're working with a worksheet where we have access to this chart, then I can make reference to those. As we go down the chart, we multiply by our powers. So a kilometer, 10 hectometers is 1 kilometer. So we're multiplying by powers of 10 as we move down. So if I was going from kilometers to centimeters, I would multiply by 10, 100, 1,000, 10,000, 100,000. So if I wanted to go from a kilometer to a centimeter, it would be multiplying by 100,000. So if I wanted to go from a gigameter to a meter, a gigameter is 10 to the power of 9 meters. So it would be 1 billion meters. A megameter would be 1 million. And giga and mega are the same terminology when we're talking about bytes. So if you're talking about the files, a kilobyte is 1,000 bytes of information. A megabyte is 1 million. A gigabyte is 1 billion. And a terabyte ends up being 1 trillion. Because they're all powers of almost 1,000 times greater. A kilometer, if I go from a kilometer to meters, how many meters in a kilometer?
1,000.
Thank you, Colin. How many centimeters in a meter? 0.01. 1/100th of a meter. How many, a millimeter is what portion of a meter? 1,000. And then a micrometer is 1 millionth, or micrometer. And a nanometer is 1 billionth of a meter. which is why a nanometer would be used when you're talking about, in biology, when you're measuring small single-celled organisms or you're looking at single cells, you're talking in terms of nanometers because it's such a small unit. How many milliliters in 1 liter?
1,000.
1,000, because I'm going from liters to milliliters, so I'm multiplying by powers of 10. How many milligrams in 1 gram?
1,000.
1,000 again. How many grams in 1 kilogram?
1,000.
1,000. How many liters in 1 milliliter? 1,000. How many grams in 1 milligram? And how many kilograms in 1 gram? 1,000th again. So there's a couple of ways that we can do conversions within the SI system. The first one is using a slide rule. So what they've done is that chart that was on the previous page, we've made it into a number line. This stands for my base unit, grams, meters, liters. And then these are our abbreviations. Deci, centi, milli, there's nano, and there's, micro and nano. Deca, hecta, kilo, mega, and giga. And each one of these tick marks refers to a power of 10. So as I'm going this way, I would be dividing by powers of 10. And as I was going this way, I'd be multiplying by powers of 10. So if I was going from 1 meter, which is my base unit, to centimeters, I'd multiply by 10, 100. So 1 meter would equal 100 centimeters. If I was going from millimeters to meters, here's my millimeters, divide by 10, divide by 100, divide by 1,000. So it would be, I could write it as 1/1000th as a fraction or as a decimal. So if I was going from liters to milliliters, there's my liters, 10, 100, 1,000. If I wrote all of these as powers of 10, 100 as a power of 10 would be 10 to the power of 2. 1/1000th to the power of 10 would be 10 to the power of -3. And 1,000 would be 10 to the power of 3. So if I look at class example number 2, I want to go from meters to centimeters. So if I look at my chart, meters to centimeters means I multiply by 100. So if I take 7.5 and multiply it by 100, I get 750. I want you to do the next 2. And then we'll check them as a class. So if I wanted to go from 72,350 milligrams to kilograms, I would divide by how much? A million. So I would get 0.072350 kilograms. from micrometers to nanometers. So micrometers to nanometers. 10, 100, 1,000. So when I write this down, I could write it down as multiplied by 1,000, or I could use my powers of 10 as well. It's times 10 to the third power. I would still get 325,000 nanometers. And that would be my abbreviation, NM. Do we continue on to class example number 3? Okay, let's take a look at class example number 3 and see if you can do those 3 questions. So if we look at class example number 3, it does say to leave the answer in scientific notation. So if I'm going from kilometers to millimeters, I've got my chart, I just moved it to the bottom. So kilometers to millimeters, that's 1, 2, 3, 4, 5, 6. So I'm multiplying by 10 to the 6th power. This 12, I can write as 1.2 times 10 to the 1st power. So then if I put those together with my exponent rules, 10 to the 1 times 10 to the 6 gives me 10 to the 7. So I get 1.2 times 10 to the 7 millimeters. If I do the same thing for B, this 580 micrograms becomes 5.80 times 10 to the 2. And then if I'm going from micro to grams, 1, 2, 3, 4, 5, 6, but because I'm moving to the left, I would put it in as a -6. So then when I multiply the powers of 10 together, I add the exponents, and I get 5.8 times 10 to the -4. So then the last one, this is centiliters. So if I take my centiliters and write it in scientific notation, I get 1.57 times 10 to the 4, because there's 4 spots to move the decimal place. And then I'm converting from centiliters to mega. So if I count 1, 2, 3, 4, 5, 6, 7, 8 spots, and because again I'm moving to the left, it's -8. Add the exponents, 4 and -8 gives me -4. So I get 1.57 times 10 to the -4 megaliters. So I'm going to give you about 10 minutes or so, and I want you to work on these questions. On question number 1, A, C, E, G, and I. Question number 2, A, C, E, and G. And then question number 3. The next method of conversion is using proportional reasoning. So if we just scroll down to class example number 3 and just jump into what proportional reasoning means, Alice, Jim, and Rima were asked to convert 300 centimeters into meters. Part of their work is shown, and they each knew that 1 meter equaled 100 centimeters. So they set them up as proportion. Alice said, if 1 meter equals 100 centimeters, then how many meters are in 300 centimeters? From here, Alice noticed that if I multiplied 100 by 3, I get 300. So she did the same thing to the top and got 3 meters. With Jim, Jim set up the exact same proportion, but then did cross multiplying. 1 times 300 equals 100 times x. The centimeters here cancel each other out, and then I get, and then he divided both sides by 100. 300 divided by 100 equals 3, and my units become meters. And then all that Rima did differently is she set up her proportion where she had 100 centimeters equals 1 meter. So she put hers on the top, still did the same cross multiplying. And if you notice, when she cross multiplied, her line in here is the exact same as Jim's, which is what will happen if you set up your proportions correctly. It doesn't matter what is on the top and what is on the bottom as long as you're consistent. Centimeters on the top, meters on the bottom. Meters on the top, centimeters on the bottom. 300 divided by 100, the centimeters will cancel out, and I'll be left with 3 meters. So when you're looking at proportional reasoning, it doesn't matter how you set it up as long as you maintain consistency between the two proportions. An alternate approach is to leave the units as headings and carry out the cross product as shown below. This part here you can read on your own because I'm not sure if that would make sense.
No, probably not.
A photograph of an African elephant has a scale of 1 centimeter representing 0.6 meters. The elephant's trunk in the photograph measures 3.5. What is the actual length of the elephant's trunk? So if I set this up as a proportion, I have a scale factor. 1 centimeter corresponds to 0.6 meters. And then the next unit that I'm given is the length of the elephant in the photograph, or the trunk. So that's 3.5 centimeters over X. Now when I do the cross multiplying, I don't worry about the units. I leave the units out because I sometimes find that they can be more confusing. So I take 1 and I multiply it by X, which will give me X. And then I take 3.5 and multiply it by 0.6. And what do I get when I multiply 3 and 5/10 by 6/10?
2 and 1/10 meters.
And my unit would be meters because that's what I'm missing down at the bottom. So now if we look at class example number 6. Reba followed a recipe for rice bean soup and used 175 milliliters of beans and 650 milliliters of rice. She realized that she did not have enough soup, so she added another 70 milliliters of beans. How much rice should she add? So if I set this up, I can set it up again as a proportion. And I can set it up a couple of different ways. I can look at it as beans to rice. She had 175 milliliters of beans to 650 milliliters of rice. And then she had 70 milliliters of beans to how many milliliters of rice? So then if I work on my cross multiplying, 175 times X equals 70 times 650. What is 70 times 650? What'd you get? Good. 4550?
Yeah.
And then divide both sides by 175. What do I get?
Yeah, another
45,000?
Yeah.
Is it 45,000 or 45,500?
Yeah. Yeah.
Okay.
That's right.
So now when I divide, what do I get?
260 milliliters.
So she needs to add 260 milliliters of rice is needed to keep my soup tasting the same. questions for this, I'm going to wait and we're going to do the next part. The last part, or the third method, looks at unit or dimensional analysis. Unit analysis works when I'm doing multiple conversions, so that I don't actually have to do the conversions one at a time. So if only one conversion is required, the basic setup approach is take the given number and multiply it by your conversion factor. That's kind of what you did in the first part. Questions, the last two class examples, we used proportions because we weren't doing straight conversions. So if I had to look at converting 75 millimeters to meters, like proportional reasoning, a known conversion is used. 1 meter equals 1,000 millimeters. So when we multiply the given is 75 millimeters is to 1, as 1 meter is to 1,000 millimeters. So when I set this up, the way that I set it up is I always make sure that my units that I want to get rid of become top and bottom, because millimeters divided by millimeters cancel out. That leaves me with just meters. So now I've got 75 divided by 1,000 and I get 0.075. I wouldn't use this to do that kind of conversion. I would use the chart and I would count by powers of 10. This tends to be a little bit more overkill. But this method, if we start practicing it now, when we get into our imperial conversions, and you have to do things like convert something from, let's say, miles to inches, this will work better because then I don't have to do all the in-between steps. So if I wanted to go from 12 kilometers to meters, the way that I would set this up using my dimensional analysis is I'd have my 12 kilometers is to 1. And then the unit that I'm converting to would go on the top, and the unit that I have would go on the bottom. And then I need to put in my conversion factor. My conversion factor being that I know 1 kilometer equals 1,000 meters. And sorry, this isn't an equal sign, this is a multiplying sign. So when I go to multiply this out, the kilometer unit on the top and the bottom cancel each other out. So my kilometers are gone, and I'm left with meters. 12 times 1,000, and I get 12,000 meters. So if I did the same thing with B, 2,730 nanometers is to 1. And I have nanometers on the bottom and meters on the top. So what I need to remember, if I go to the previous page where my number line was, if I'm going from nanometers to meters, I've got 1, 2, 3, 4, 5, 6. So it's a 10 to the power of 6 conversion. So I can do this one of two ways. I can say that 10 to the power of 6 nanometers equals 1 meter. Or I could go the other way where I could say 10 to the power of negative 6 meters equals 1 nanometer. If I have a power of 10, so let's say I use the green system. If I have a power of 10 here, I'm going to change this to a power of 10 by putting it in scientific notation. And then I can multiply my other power of 10. when the exponents are the same, or sorry, when the bases are the same and I'm multiplying, what do I do with the exponents? Add them. So 4 plus negative 6. So I get 2.73 times 10 to the negative 2 meters. Did I use the right conversion?
It's times 10 to the
Power
power
of 9, right?
No, to the power of 3. You see where you put 2.730?
Oh, right. No, but I think my conversion to nanometers is wrong.
Oh, yeah, maybe.
I don't think it's 10 to the power of 6. Go back. I think it's 10 to the 9. I think I grabbed it wrong.
It's 10 to the 9.
10 to the 9. Okay. So this would be 10 to the negative 9, or 10 to the positive 9 if I put it on the bottom. So now when I add the exponents, 3 plus negative 9, negative 6. That's better. So where this can help is, let's say I wanted to go from a big unit like kilometers to millimeters. Especially if I didn't have that chart in front of me where I couldn't count. What I might decide to do is take 2 steps and go to meters first. Because this part here I should know, 1,000 meters in 1 kilometer. And then I might take my next conversion to millimeters. 1,000 millimeters in 1 meter. And if I'm doing all of this multiplying, if you notice, the kilometers canceled out and the meters canceled out. And then what I'm left with is millimeters, and I multiply by all of this. So 2.4 times 1,000 times 1,000 gives me 2,400,000 millimeters. So I'm going to skip question number 8, and I'm going to go to question number 9. Zimmer needs to convert 50 meters per second to kilometers per minute. This is a question you may have had to do even in physics. So in order to solve this problem, what does Zimmer need to know? I want to go from meters per second to kilometers per minute.
How many seconds in a minute?
So how many seconds in a minute?
60.
So 1 minute equals 60 seconds. What else does he need to know? What else do I need to know?
Just how many meters
So 1 kilometer equals 1,000 meters. So I want to go from meters per second to kilometers per minute. So if I want kilometers to be on the top, or kilometers to come first, they need to be on the top, which means my meters need to go. So if my meters are down below, I have that 1 kilometer is 1,000 meters. And then I have my seconds to minutes. 60 seconds is equivalent to 1 minute. And if I look at my units that I can cancel, meters on the top canceled with the meters on the bottom. Seconds on the bottom canceled out with seconds on the top. This is 50 meters per 1 second, if I wanted to put a unit there. If I start multiplying this out, I've got 50 times 1 times 60 over 1 times 1,000 times 1. So it's 50 times 60. 3,000. So then 3,000 divided by 1,000. And this becomes 3 kilometers per minute. for dimension analysis, I don't need to do it this way. What I could do is I could figure out, well, if I go 50 meters for 1 second, I know that there are 1,000 kilometers, or sorry, 1,000 meters in a kilometer. So then I could make my conversion, I could do my conversions one step at a time. I wouldn't have to set it up as a unit analysis. And I would still end up with my 3 kilometers per minute in the end. Because this would become 0.05 kilometers for every 1 second. And then 1 second is 1/60th of a minute. And if I took my calculator and I went 0.05 divided by 1/60th, I will get 3. Right? Do I get 3, Tyrone? And there's my 3 kilometers per minute. So I don't necessarily have to do it in 1 step. I could do it in multiple steps, and I will still get to the same point. So the questions that I would like you to continue on . Question number 5 and 6. Question number 9, A and E. And then 10 to 16.